right, here's our second video of 11.7. Remember in our first video we talked about independent events, where the outcome of the second one is not affected by what happened the first time. Now we're going to talk about what we call dependent events, where two events are dependent if the occurrence of one of them has an effect on the probability of the other. So whatever happened first determines or could determine or change the outcome of what happened second. They depend on each other, okay? So if I have a dependent event and I want to figure out the probability of A and B, then I have to find the probability of A happening, the first event happening, and then I've got to figure out the probability of B happening given that A has already occurred. What happened the first time that's going to affect the probability of my second event? And then I can multiply them together. Let me show you a few examples of this idea. Example number 4 says you have won a free trip to Madrid and you can take 2 people with you. All expenses paid. Bad news. 10 of your cousins have appeared out of nowhere and are begging you to take them. You write each cousin's name on a card, place the card in a hat, and select one name. Then you select a second name without replacing the first card. You wouldn't want to put the first card in there because you've already picked that cousin to go with you. If 3 of your 10 cousins speak Spanish, find the probability of selecting 2 Spanish-speaking cousins. You want to pick one cousin, name out of a hat. You don't want to put it back. Then you want to pick another name of a second cousin. What's the probability that both of them will speak Spanish? Okay, let's think about this. The first time you go to pick, how many names do you have in the hat total? And out of those, how many speak Spanish? So what's the probability that the first person you pick will speak Spanish? Well, isn't that 3 out of 10? You have 3 cousins that speak Spanish. There's 10 names in the hat. 3 out of 10 would speak Spanish. And then you're going to go pick a second card. I heard the word and, so I'm going to multiply. I'm going to pick a card and then pick another card. But be careful, I didn't put the first card back. So if I didn't put the first card back, then what's the probability when I go to pick a second card that that cousin speaks Spanish? Oh, did you say 2 out of 9 this time? 2, because when you picked the first time, if that cousin spoke Spanish and you didn't put that card back, you have 1 less cousin that speaks Spanish, and then you have 1 less card in the hat, and so now you have 2 out of 9. It depends on what happened the first time. So to figure out the probability of picking 2 cousins that speak Spanish, you're going to do 3 out of 10 times 2 out of 9. Final answer reduced would be 1/15, or you could say 0.07, a 7% chance that both those cousins will speak Spanish. Here's another one. Example number 5 says 3 people are randomly selected, 1 person at a time, from 5 freshmen, 2 sophomores, and 4 juniors. Find the probability that the first 2 people selected are freshmen and the third is a junior. I want it to be a freshman, and then another freshman, and then a junior. And again, did you hear the key words? Freshman and junior. And so I hear the word and so that means I'm going to multiply. But now, if I pick a freshman the first time, and I go to pick a second person, if I've already picked a freshman, doesn't that second event depend on what happened the first time? So these are my dependent events again. And so I've got to figure out the probability of picking a freshman and a junior, but I've got to be careful about what I pick the first time and the second time. When I go to pick that first freshman, how many freshmen are there out of how many total students? 5 out of 11, right? When I go to pick the next freshman though, how many freshmen are there out of how many total students? Well, I can't pick that same freshman from before, and so now I'm down to 4 out of 10. I have 4 freshmen left out of 10 students left because I've already picked a person the first time. And then when I go to pick a junior, how many juniors do I have left out of how many students are left? Well, I still have 4 juniors, but I only have 9 students left. I have 5 out of 11 times 4 out of 10 times 4 out of 9. Do you see how it decreases every single time because the total number of students goes down? I ended up getting 8 out of 99 as a reduced fraction or probability that I'll pick a freshman and then a junior. All right, make sure you hear those key words. But like I said, it doesn't actually say and in the problem all the time. So you've got to be really careful to read it carefully and kind of interpret. Is this a dependent or an independent event? Are they asking you for an or problem or an and problem? Remember, if it's an or problem, we're going to add, and if it's an and problem, we're going to multiply. Keep practicing. We got one more video in this section.